Good morning, good afternoon, good evening, ladies and gentlemen. I am Elon Lee from American Heritage High School, and I will be introducing you about my team's Mars rover design. The topic of the slide is called Mars Future and Serenity. It is developed by 5 Gigabytes development team, which consists me, Elon Lee, Bernardo Ritz, Mark Ma, and Felix Almo. And here's the table of contents, which introduce the background, the physical product, which is just the hardware, technical product, which is the software, and lastly, the investments we're seeking from all over the world. Let's talk about the background. First of all, who are we and our missions? With the help of robots, humanity expanded to the entire galaxy. These words, written by one of the greatest science fiction author of all time, Isaac Asimov. He painted a vision of a future where humanity conquers the stars. What was once a distant dream is now within our grasp. For thousands of years, we have looked up at the night sky, wondering what lies beyond. From Galileo's first telescope to Apollo 11 moon landing, we have always been explorers. And now, we stand at the threshold for the next great leap, Mars. This moment is not just another milestone in space exploration, it is the defining moment which we decide if we will remain confined to Earth or to take our place amongst the stars. Mars, our next great frontier, has long been a symbol of mystery, danger, and possibility. From ancient mythology to modern science fiction, it has captivated our imaginations. But today, it is not just a dream. It is a real, tangible goal that we can achieve within our lifetimes. Yet, despite our intelligence and innovation, one fundamental truth remains: humanity is not built for space. The challenges of human space exploration is immense, as we humans are remarkable creatures. Our ability to think critically, create, and innovate has propelled us to the top of the evolutionary chain. We have built civilizations, unlocked the mysteries of the universe, and even set our foot on the moon. But for all our intelligence, our biology remains fragile. Space is one of the most hostile environments imaginable. Unlike Earth, where our atmosphere protects us from radiation and provides air to breathe, Mars or space has a much harder time for humans to survive as they offer no such luxuries. For example, extreme temperatures in space temperature can swing from negative 250 Fahrenheit to over 250 Fahrenheit in minutes. On Mars, the surface can drop to negative 80 Fahrenheit, making human survival nearly impossible without extensive life support systems. Secondly, we can talk about the cosmic radiation. Without Earth's magnetic field to protect us, astronauts will be bombarded with dangerous radiation such as X-ray, gamma rays, increasing the risk of cancer and other diseases, or cause them to die within seconds, as all these rays contain high energy that could instantly destroy human cells. Lack of resources. Unlike Earth, Mars has no liquid water, which means that also no breathable air and no food resources. Everything we need to survive must be brought with us onto Mars, which create a lot more problems, such as the issue during transportation, the expiry date of all the needed items, and such. And then we have low gravity effects, which is the last part, as extended exposure to low gravity causes muscle atrophy. As we all know that Earth is constantly applying the gravity onto us, which means that it is constantly testing our muscles and keeping our shape together. However, in space, there is zero gravity, so it means that your muscles are constantly in a relaxed state, which it doesn't do anything. And the human body has its mechanism that it automatically reduces the energy output, which are the muscles, when they are not needed. So therefore, you can experience bone loss, muscle atrophy, and a lot of other health complications, as human body are not suited for the zero gravity environment, therefore making the long-term human missions extremely difficult. So this means that before human can safely set foot on Mars, we need machines, robust, autonomous, and efficient robots that can explore, gather data, and pave the way for future colonialization. And this is where Serenity comes in. Introduces Serenity, the future of Martian exploration. Our team, 5 gigabytes, was entrusted with a critical mission to design a machine that can traverse the Martian landscape, gather crucial data, and serve as the foundation for future space exploration. From this vision, Serenity, as you've seen in the picture on the right side, was born. Serenity is not just another Mars rover like everyone else. It is an advanced robotic explorer designed for resilience, intelligence, and most importantly, efficiency. Let's take a closer look at what makes it unique. Second part, let's talk about the physical product, which are the hardwares built on the Serenity, the components, and the overall photos of it. Serenity is built to survive and is engineering for endurance. Its robust chassis shielded from the harsh condition of Mars, ensuring it can withstand high winds, dust storms, and extreme temperatures, which are more than just commonly seen on Mars, but also all across the universe on countless planets that can be set foot on. Secondly, we have tread and motors. Serenity features a heavy-duty motors and rock treads, allowing it to traverse through rocky terrain, sand dunes, and steep inclines without getting stuck. And these features are especially important for Mars terrain traversing, as the Mars terrain, unlike Earth, are combined with all three of the listed above and countless other tough terrains that just simply wheels or similar biological legs would not be able to fulfill the mission with. And then thirdly, we have the Raspberry Pi core, and its heart lies at Raspberry Pi, which serve as a central processor managing movement and communication with mission control. What does that mean? So it serves as the robot's brain. It allows it for logical thinking, allows the direct communication between the controller and the robot itself, and most importantly, it says command to tell which every single part of the robot what to do, which is the same as a human brain functions. It's just that it functions on electricity and signaling with combined with binary data, zeros and ones, instead of biological electricity data through human neurons. And then we have the HD camera system. Serenity is equipped with high-definition camera and provides a real-time 30 frames per second video with a 55-degree field of view, allowing the scientist and controller to analyze Mars surface in detail. This feature is also used for its auto routing that controls the robot by itself when the controllers are not on their workstation. And it also allows the controller to mm, directly guide the robot to where the mission needs it to go. Overall, it is one of the most crucial part within the robot design. And yes, here are the dissection, or well, dissection would be the word. It would be the more specific details about the robot's components. So on the top left picture, we can see there is the battery, the motor head, and the Raspberry Pi. So what does these do? Battery, as well, obviously suggests in its name, as the energy resource for the whole Mars rover to function. It serves as the source of power, and without it, the Mars rover simply wouldn't be able to function at all. It wouldn't able to start a Raspberry Pi. It wouldn't able to power its motor. It wouldn't even be able to transport any communication between the controller and a robot. And then let's move on to the top right picture. As you can see, there is the camera and there's the motor wheel, camera holder, and the wheels. So what are these two? Camera are being placed on the top of the camera holder, and the camera holder is a bar metal designed directly for the mission. It is 1 inch by 1 inch in width, 2 inch in the length, and then around 8 inch, 6 to 8 inches for height. It can vary based on the mission needed. And the camera is directly placed on top. And why does it have to be on top instead of in front of the camera? You may wonder. And the reason to that is it provides a higher degree of vision of freedom. When you are placing the camera directly in front of the robots, all they can see is a small area in front of it, which will be represented like a cone shape. However, when you put it at a higher level, it actually provides a much larger scale for every single inch it goes up to. And we choose that 6 inches is because the mission needed for line tracking only needs 6 inches, which provides us with 55-degree field of vision. And then we have the motor wheels and the wheels. The wheels are for transport, moving purposes and motion purposes, and it serves as part of the components that make the trail functional. And then we have the motor wheel, which is one of the wheels that which is the single wheel that directly provides power from the motor. Without a motor wheel, the rest of the wheels are just decoration and it just wouldn't move. Let's move on to the bottom left pictures. There are the motors and the step-down converter. Let's first talk about the motors. For the motors, we used WASP with 6 volt voltage as input, and it should provide efficient horsepower to power the whole Mars rover to traverse through Martian terrains. And let's move to the step-down converter. The step-down converter is there for converting the power voltage to downsize a little bit. As we're using a 9-volt battery right now, and the only voltage needed for the motor and the Raspberry Pi is going to be 6 volts and 3 volts. So therefore, we would need a step-down converter to downsize the electricity flowing through the robot's wires so that it wouldn't directly burn or damage the robot's Raspberry Pi or its brain or the motors that keeps the whole robot moving. And in the middle, you can see the wires that are being organized into a circular shape to keep it from dragging outside the robot and become an obstacle movement. And then lastly, on the bottom right picture, you can see it, Mars rover, which is Serenity, moving on a simulated track that will be that's designed to simulate the Mars surface. And we can see his treads are perfectly fitting inside the lane, and his camera is ready for the slide detection for to automatically move forward. And that's about the hardware part. Now let's move on to something even more exciting. Software, which are the technical products. And we'll talk about the components and the demo screen. First of all, let's talk about advanced software and security features. Unlike traditional rovers that rely directly on human control, which means that it will just went into a shutdown state when no one is on the control station, Serenity features intelligent automation and security measures. First of all, let's talk about the wireless control interface. It is a user-friendly dashboard that allows scientists, engineers, and overall drivers to control Serenity remotely from Earth, and while directing its movements with high precision. Overall, it is the most traditional way to pilot a Mars rover, which is through the direct communication. However, our robot is more advanced, as in the past, usually there is a delay between the telecommunication of Mars and Earth since there is a distance. However, with our advanced technology built on Serenity, we are able to provide nearly instant, or what we call um, real-time video live stream to the users on Earth, which is a much higher improvement than the past Mars rovers. Secondly, let's move on to the secure logging screens. To protect against cyber threats, only authorized personnel can access Serenity's control system, similar to many other robots, ensuring the mission remains secure. As the internet has expanded and developed in the past years, cybersecurity has become an issue not just within the personal information or personal data, but also with the highly secretive informations, as not as individuals, organization, groups, or even countries are consistently trying to attack each other's network interface or to steal valuable data or to gather valuable information. And the Mars rover as experiment and research will exactly be one of those data the organization will be trying to protect. Therefore, we designed this secure login screen that asks the prompts the user to enter their username and their password, which is securely stored in the data in a database that can only access via our SQL, as we also saw SQLite, which is a function that accesses the database through prompting the user. And overall, it provides a much more secure option for any organizations that wish to keep their data private against the public. And let's move on to the bottom left, which is the user logbook. Every movement Serenity execute is automatically logged, allowing for real-time tracking and performance analysis, which means that this logbook serves this function by preventing the user to repeatedly hit the same movement, as every single action hit by the user will be recorded down and put onto the main logbook, so the user wouldn't be able to forget what he/she did in the past movement directions. And then lastly, we have the line detection system, which is the most important and unique feature about Serenity, our Mars rover. Our team has developed a especially cutting-edge line detection feature, which enables Serenity to navigate complex paths autonomously and reducing the need for constant human oversight. And why is that? As in the past, the efficiency for Mars rover researchers are largely reduced based due to driver constantly need to be on the station to control the robot's every movement, guiding where to go and telling what to do. However, with our current line detection and automation system, we are able to solve that problem through providing artificial intelligence interference that directly so the robots can know by itself what to do, as it has has an algorithm that provides with logical thinking. All the human operator need to do most of the time is providing its goal and just wait for it to complete its task and retrieve the data and sample needed. So it is a absolutely revolutionary it is a revolutionary design as it directly cut down the budget for human intervention by half, as the controller now doesn't need to be on the station 24/7. And here will be the interface demonstration, which is also called the GUI. The GUI is directly attached to another thing called the API and the API to the robot. The API serve as a sort of a translator that will translate your commands from the user interface into the robot on Mars directly. And it is done through a process called pipe. Pipe opens a telecommunication system between the robot and the GUI, and it allows direct data transfer with much higher speed than other methods. However, it does come with a security risk that people will try to hack into your open pipe. However, as mentioned before, our our GUI, our secure login solved that problem perfectly by only allowing authorized personnel to connect into our GUI and access the robot's private information. As you see, there's four columns, and at the top left is the video live stream, which works by directly transporting the image the robot is receiving on Mars, allowing the user to directly interfere and monitor what is going on around or in front of the robot. And then the bottom left, we have something called image overlay. And how image overlay functions is that it pictures out the overall terrain around the Mars rover that needs to traverse. It outlines the edges of these terrains and basically graph out the surface area that it can safely pass through. And then, based on these data, it draws out a center line, which guides it automatically past these difficult terrains. For example, we have a line that goes straight and curve 90 degrees the other side and goes straight forward. Then the robot will first mark out the sidelines with blue colors, which we use in the program, and then mark out the center line using a green line that tells the robot what to do and where to go. And overall, following this line allows the robot to automatically move around without human intervention and perform a variety of tasks that's never been thought able to do by its robot itself. And then top right, we have the control panel, which, as the name suggests, controls the robot's movement directly from Earth all the way to Mars. And as you can see, there's a up, down, left, right button, and there's a stop in the middle. And there's a corresponding by moving forward, moving backward, turning leftward, turning rightward, and stopping all robot motion. This interface is unique in that it's much more faster and much has a higher efficiency in communication between Mars and the Earth, as I suggested before, as we are using our special API. And then the bottom right is going to be the log screen, as I talked about before. It records every single move the robot has done and every single thing that is received, every single command that executed, received, executed, and reported. For example, if I press the top button once, but top button once, the bottom four ones, backward ones, leftward ones, and rightward ones, we will have no idea if the robot actually moved or not because it's going back to the same place. However, at this moment, the lock screen will tell you exactly what the user or the operator has done to the robot, so you will know what step would you take next instead of just like standing there and not knowing what to do. It also serves as part of the code function that allows the robot to automatically move according to the central line mentioned before. Let's move on to the next point. And the importance of Mars exploration at this point is some may ask, why Mars? Why invest in a mission that focuses on an habitable planet? Therefore, let's bring up our financial details. The answer to that question is simple. Mars is the key to our future. Throughout history, every great civilization has expanded beyond its borders to secure resources, opportunities, and survival. The same principle applies to humanity as a whole across the galaxy. Scientific discovery here. Studying Mars can teach us about the history of solar system, the potential for past life, and even space, even Earth's own future. As for the current research conducted, there is sign that there was H2O, which is water, exists on Mars. At least there was at the time. And then, due to some mysterious circumstances or um, the lack of a second solar body around its orbital, Mars polar Mars polar suddenly disappeared, allowing the solar wind to constantly brush its surface with high energy radiations, and which directly destroyed all natural habitat or potentially existing natural habitat and the overall atmosphere on Mars. However, those habitat has been put down to those habitats remained. As if we can establish our presence on Mars, we can take the first step toward making humanity as a multi-planetary species, ensuring our survival beyond Earth. Let's also talk about technological advancement. The challenges of Mars exploration drives innovation, leading to breakthrough in robotics, AI, renewable energy, and life support systems that benefit industry on Earth. Investing in Mars is not just about space, it's about advancing human civilization as a whole. Therefore, let's move on to the financial details. Why invest in Serenity? Why invest in us? Now let's talk about financials. We're seeking a $600,000 in funding to take Serenity to the next level. And here's how this investment will be utilized. Mass production will be $500,000 as we plan to manufacture 500 Serenity units, each costing $1,000 to produce, as shown in the details. Secondly, will be the manufacturing equipment will be the $50,000 and it's going to be the specialized machinery that is needed for efficient production and quality control, which this includes all the machines needed in the factories and all the software's functions need to be searched from the internet or bought from the internet. They're all concluded within this $50,000. Let's move on to risk management, which will be $30,000 combined. It is a safety net to cover unforeseen challenges during manufacturing and deployment, as there is always unexpected circumstances during the development process and the deploying process, and this budget is designed directly for those incidents and to make sure the team wouldn't be in a rush to find a solution when something unexpected happens. And let's talk about the marketing and partnerships, which will be $20,000 be put into use. We're aiming forward to establishing collaboration with research institutions, aerospace companies, and overall investors, such as large companies like SpaceX, Google, DeepMind, DeepSeek, and all these advanced companies that are having a goal to dive into this field. Now let's move on to the project growth and investor returns. Over the next 5 years, we project a total revenue of $3.15 million, and they are based on the following details. And let's first talk about the robot sales. Robot sales will be $500,000, which means that we're selling 250 Serenity units at a 100% markup of $2,000 each. And the research sample sales will be 2.5 million as we're selling 250 research samples at $10,000 per piece to the space agencies, universities, and organizations. As these organizations are usually eagerly to retrieve these research samples to get ahead in the research field, which are the perfect opportunities for us to sell our research pieces to. And then we have the partnership collaborations, which will be another $150,000. Securing deals with companies like SpaceX, Lockheed Martin, Blue Origin, Google, OpenAI, and all these companies should improve collaboration with all these companies will provide us with a constant and sustainable sustainable finance stream. And then lastly, for investors, what does all this mean? This means a return of $600,000 plus 30% of the remaining revenue, a lucrative opportunity that combines financial gain with pioneering space exploration. This is our movement. This is our moment. Humanity has always been defined by the ability to explore, innovate, and push beyond the limit of what is possible, and this is directly the chance for all people to join.